Hey guys, this is Mrs. Furlow. I'm here to hopefully do the screencastify thing correctly and walk you through the rock cycle notes. This should be review for you from fourth grade, and then you touched on it a little bit in fifth, but if it's brand new, don't worry about it. What you're going to want up on your computer are the two things that I attached to today's assignment. The rock cycle notes should be up in one window, and your PowerPoint that I put up is in another. And the PowerPoint today is going to start on slide 42. And I want to show you really quickly how you can make a split screen on your computer. I know I typed it out last week, but it's really going to be helpful when we're going over Google Slides, that you can have one section of your computer for the slides open and the other one where you can type directly into your notes at the same time. That way you don't have to fuss and print things out. So I'm going to drag the tab so that it opens up in its own window. What I did there again was I held down the mouse and I pulled it so that it opened on its own. I'm next going to click in this area and I'm going to drag it over to the corner. See how that window shows that it is halfway? I'm going to just drop it once that window shows up. And now you see the slides in one half, and you do the same thing for the rock cycle notes. You click it and drag it down. It becomes its own window, and you can then slide it to the other half of the screen. And ta-da, your notes are on one side, and you can go back and put your notes are on one side and the Google Slides are on the other, and you can scroll through both of them at the same time. So that will really help you as we're going through. Obviously, I don't need the notes up. I know this stuff. So review from the week that we left so suddenly. We've learned that the Earth is made up of 4 compositional layers. That's the inner core that's solid iron, the outer core that is liquid iron, the mantle, which is that thickest layer, and then the crust, which is the itty bitty, really thin, up to 25 kilometers max at the very top where we live. And we learned about tectonic plates, how they move, why they move due to convection currents, and also the things that happen where those plates intersect. So earthquakes, fault lines, rift valleys, those things. And now we're going to move into rock cycle. So these are our notes. I took pity on you guys because you're doing this from home. And I highlighted everything that you need to write is in blue this time. So I'm going to go ahead to present, and here we go. All right, so what are rocks? Rocks are naturally occurring substances that make up most of our Earth's crust, which is misspelled here because I'm me. I'm me whether I'm at school or home. There you go. All right, so basically rocks make up most of the crust. That's what we're standing on now. And what are the rocks actually made out of? Well, rocks are made out of minerals, and minerals are inorganic, which means that they are not and never have been living. They are not something that's dead. They're something that has never had life. And minerals, you can think of them as little Lego pieces. They all have unique properties that are just for them. So like the 4 square blue Lego piece is unique, and every 4 square blue Lego piece is identical. That's one type of mineral. Well, a rock can be made of a whole bunch of different Lego pieces, but each individual mineral is the same, whether it's part of one rock or another. So how are rocks formed? Those minerals, those Lego pieces, undergo extreme processes of heat. Remember how hot the inner core is. High pressure, cementation, which we'll go over, and melting. All right, there are 3 main types of rocks that form on Earth, and they're identified, or they're categorized by the way that they form. So it's not their color or where they're found, it's how they were made. That's how you can determine which category that rock goes into. The 3 types are igneous, metamorphic, and sedimentary. Okay, Obviously, I found a cringy video for you that I'll play, but first we'll go through the information on the slide. The first rock type that we're going to talk about is igneous rock. Igneous rock forms when magma cools and hardens. So magma, remember, is lava that's underground. And once magma comes up to the Earth's surface, it becomes lava. That's what we call it. It's the same substance, but it's going to cool and harden. When it hardens, that's a rock. That's a rock type. I'm talking right now about extrusive igneous rock. Extrusive is a really fancy scientific term that says that it's formed on the surface of Earth. So when that magma becomes lava and the lava cools down, that is extrusive igneous rock. Now, on the other hand, there's intrusive igneous rock. So you have this big magma chamber inside of a volcano, okay? Here's the magma chamber. And that magma chamber, it's all hot, but different degrees. Obviously, the further down you go, the more heat and pressure there are, so the magma is liquid. But here in the little vents, that magma, even though it's still underground, can cool and harden and form a rock. That is an intrusive igneous rock. That means that it formed underneath the Earth's surface. So just like magma and lava, they're both igneous rocks, but there's intrusive, which is inside like magma, and there's extrusive, which is outside like lava, sorry. Okay, so characteristics. Igneous rock may have holes like this pumice down here. Or it may be smooth and shiny like obsidian, which I am currently blocking. There you go. So it may be smooth and shiny like obsidian, you Minecraft people are familiar with. So the characteristics are that it can be very varied, frankly. It has either holes or it's smooth and shiny. Examples are pumice or basalt. Basalt is the most common rock type. That is an extrusive igneous rock. Extrusive because it makes up the ocean floor, which means it's not down inside the crust. So it's an extrusive igneous rock. In obsidian, on the other hand, is an intrusive igneous rock. That forms underneath the Earth's surface, hence you having to mine it in Minecraft, right? So you have to dig for it because it's intrusive. It forms inside the Earth. But they're all types of igneous rock. Remember, igneous rock describes how it's formed. So if magma or lava cools and hardens, it's an igneous rock, no matter where it is. Okay, next we're going to go into sedimentary rock. Oh, wait, I forgot to torture you. I'll just give you a few minutes.
Shall we?
Oh, yes.
Deep down just below the crust, you'll find the mantle. Above it, magma floats around, too hot to handle. The mantle's heat makes magma ooze up to the surface. We're cooling off and forming rocks. Is its purpose.
I'm not proud of myself.
Igneous rocks are
I
called
am.
intrusive rocks when they're formed in the crust. Granite is one, and because it cools slowly, large crystals are a must. Extrusive rocks are the ones formed from magma shot out of the ground. You'll find lots of pumice and lava too where volcanoes abound.
So obviously extrusive rock is going to be found in places where the magma has risen up to the surface, right? Because extrusive means that it is formed above ground. So that's volcanoes, some trenches, any place where magma has a chance to become lava and flow, you'll find extrusive rock. That is igneous. Right now we're going to talk about the second one, which is sedimentary. All right, sedimentary is formed by weathering and erosion. Weathering and erosion is basically you have a rock and over time, it's hit by particles in the wind. It is hit by rain. And it slowly wears down. I mean, obviously rain is not going to wear a rock down immediately, but over millions of years, little particles of the rock, the surface of the rock is going to wear away. And that is weathering, and then taking that weathered piece of rock and moving it to a different spot is erosion. So surface materials such as sand, pebbles, and fossils accumulate into layers and harden into rock through compacting and cementation. So rocks up high on a hill are going to wear down, and those particles are going to be transported down to the base of the mountain or the hill. And over time, there's a layer that forms of those particles. And that layer is going to get heavier and heavier, and it's going to start to get buried. And as that happens, it's smushed together. All those particles are smushed together, and that's called cementation. And that is how you form another type of rock, which is the sedimentary rock. So characteristics in the sedimentary rock are pebbles and particles. If you see pebbles and particles, then you have what's called a conglomerate rock. A conglomerate rock, like this one here, you can tell the different pieces that were smushed together, basically, that were cemented to make that rock. So that is conglomerate. It's not all one piece. This is another, let me move this window. This is another type of conglomerate rock where you can tell the different pieces that were smushed together. You can also see fossils only in sedimentary rock, and that's really important. So where you are writing fossils and shells on your sheet, you might want to star it or highlight it a different color. That is a big takeaway here. Okay, there are 3 types of rocks. That's one takeaway. Igneous rocks are ones that form when magma cools. Sedimentary rocks are formed through layering and cementation, and that's where fossils are. Those are the big points so far today. Other examples are limestone, shale, which it's not a conglomerate rock. See how shale is smooth, and you don't see a bunch of the different pebbles and parts of it. It looks like it's just one type of rock, but actually shale is really kind of cool as far as rocks go. And you can peel layers of shale off, kind of like you're peeling off nail polish, frankly. You can take layer by layer off. Now, it's not as soft as peeling off nail polish, but if you break shale, it's going to break along certain planes, and that is a characteristic of it. So even though it doesn't look like it's layered rock, because it looks like it's all one piece, when you break shale, you can definitely tell that it is sedimentary. And then siltstone as well. And then I'm going to finish out today with this YouTube clip, and it will explain sedimentary rock a little bit better, and I'll be back again tomorrow.
This polished marble is an example of the third main type of rock, known as metamorphic rock. The striking patterns and colours created when marble was formed from other rocks make it a popular decorative stone. Metamorphic rocks are formed by the partial melting of rocks deep underground. Other types of rock, like sedimentary and igneous, get crushed and melted either by the huge pressure of rock around them or by the heat from nearby magma, or a combination of both. They change, which is what metamorphosis means, into metamorphic rock.
Okay, so it looks like that is my metamorphic rock and not my sedimentary. Yikes, sorry about that.
The second main type of rock is called sedimentary. It's made up, as its name suggests, of sediment, small pieces of other rocks and animal remains which have already been broken down by a process called weathering. Weathering is what happens when rocks are eroded away by the action of wind and water. over thousands, even millions of years, little pieces of